All right. What I want to do first today is revisit what we did yesterday. We did the same lesson except we weren't doing what? Geometric. We were doing arithmetic, okay? Yesterday's lesson was arithmetic, so when we were doing that, we started with this formula. Yes? Then we talked about arithmetic means. Remember that? What did that mean? Like if I told you this term and I told you this term, you would put some more terms in there and then you'd say you took this one plus how many differences to get to this one. That was arithmetic means. Remember where you drew the little blanks to figure out how many times? It'd make more sense if I had numbers there, but I figured if I made up numbers, someone would try to do it and it won't work out. So, but do you remember doing that? Put the little blanks in. Okay. Then we did sum. We had a sum formula, and remember, anybody remember the sum formula? Okay. N over 2, number of terms divided by 2, times the sum of the first term plus the last term, right? The last term being a sub n. So if you're adding 10 terms, n is 10. This is term 10, and this is 10 divided by 2, first term plus last term, 10th term. We good? We're going to do all that same stuff today for geometric sequences, okay? And guess what? All the formulas are different. All right? Well, it's not that bad because we already know some of them are going to be on the quiz. Geometric sequence means they have a common ratio. So anybody remember the explicit form that'll be on the quiz? Take the first term and you don't add, you multiply. And how do you say you multiply it over and over and over? Okay, it's an exponent and it's n minus 1 because we don't, to get the first term, we don't have to multiply, right? After that, we multiply. Ready remembering? Okay. So that was here. We already did this. One little reminder here. It says, watch out. Remember, not all sequences are arithmetic or geometric. So if I put this sequence on the quiz, it just says, and all I would ask you is like, find the next 3 terms, okay? But if I put this, any ideas? So you could find the next 3? You'd add 11, add 13, add 15, yes? Okay. But the problem is students see this question and they go, okay, they added 3. So then they just add a bunch of 3s on the back. You have to go beyond the first time to make sure that that's really happening, right? Any questions? All right, so just a reminder that not all sequences are one or the other. I am not going to ask you to find a sum or a formula for anything crazy like that. It would just say, figure out what the next few terms would be. All right, we're good. We already know that one. So how do you find the 7th term in this sequence? So how would we do that? 8 times? Okay. How do you find R, guys, when you don't know? Yeah. Take any term divided by the previous term. Same thing would work if you did 72 divided by negative 24, you'd get negative 3. And it's 6th power, to the 7 minus 1. Do I need parentheses? Okay. I got a lot of this when people ask to write explicit form for this question. I'm really not happy with either one of those. Okay? They're not going to give you the right answer unless n happen to be odd or something. Because what even one wouldn't work. Because when you put this in, if you don't put a parenthesis here, it's going to take 3 to the n minus 1 and then take the opposite. Everybody okay with that? Just be careful. Your parentheses need to be around the negative number. Same if it's a fraction or decimal, make sure you put parentheses. I just always put parentheses. I should write it this way when I write it, okay? That being said, did someone get an answer here? Does this one come out an ugly decimal that you can't really? No. It comes out a nice number. It's not a decimal. Positive, yes? We good? Thank you. All right, geometric means. When we did arithmetic means, it meant we put in some extra blanks, then we figured out. So this one, geometric, instead of how many times did we add the difference, it's going to be what? Multiplied, yeah. This is R, so you would have 480 equal, times R 3 times to get negative 7.5, and then you'd have to divide and cube root. Let's not do that one. Let's do this one. I will tell you on the quiz, it's not going to give you the little blanks. You're going to have to know that when it says 2 geometric means that you have to put 2 blanks in there. Does that make sense? And I always do the blanks. I know I shouldn't have to do the blanks, but I always do because I'm thinking I want to make sure how many R's I multiplied by. Then I cry a little. Then I do one with 2, I do one with 3 till I figure out the pattern and make sure that I know it's one more than the number of blanks, right? Okay, so if there's 2 blanks, we multiplied by R 3 times to get to that last one. So 162 divided by 6 is 27. Now, most of you know that one in your head, but how do you do a cube root? Yes, you can use the math key. There's a cube root there, but we're going to do later today, I think, a 7th root and a 9th root or something stupid. Okay. I don't want to have to figure out how to do a 9th root. Can I just do both sides to the 1/3 power? Okay, so we get R is 3. Are we done? Self-checking question though, right? 6 times 3 is 18. 18 times 3 is 54. And 54 times 3 better come out 162 or we did something wrong. It should come out really, even if R was some disgusting decimal, it should come out close to 162 or you did something wrong of finding what you're multiplying by. All right. Determine the common ratio in the next 3 terms in this sequence. This is a totally weird sequence. Multiplying by 2? How would you triple check that? Take any term divided by the previous term. No killing kittens, yes? You would have to factor the 2 out of the top. Yeah, well, imagine that. Other people who don't have Miss Hopper don't know what that means to kill kittens. Okay. Because somebody would do, this goes in here twice, this goes in here twice, 2 plus 2 is 4, right? No. That's killing kitten. Okay. So this had a ratio of 2. What would the next 3 terms be? $32, $64. I think we can multiply by 2, guys. Come on. All right. Find the 7th term. This is a mess, but if we're told it's geometric, divide negative 47.1 divided by 157 gives us an R of, okay. This is an interesting question because I think some people's calculator might change it to a decimal and or fraction and some won't. But what are we going to do to find the seventh term? How many times? 7 minus 1 is 6. So 157. Everybody type this in because I want you to see how some of the calculators, I think this is the problem anyway, where some will change it to a decimal and some won't. Actually, I'm thinking I lied. This is the problem. Nobody's will. Did anybody get it to change it to a fraction? Is it an exact answer, though? Why do you think it's an exact answer? Okay. Yeah, your calculator goes to like 13 places or something, and this definitely is not. Can I show you real quick how you would do this as an exact answer if it was being real picky on the quiz and it wanted an exact answer and you weren't sure? What is the fraction? What is the fraction for negative 0.3? Negative 3/10. Everybody okay? It's not 1/3. They tried to tell me fifth period. What's the decimal for 1/3? 0.3 repeating, right? This is 3/10. All right, to the sixth power. This is what you would do, guys. You could type 157 times negative 3 to the sixth over 10 to the sixth, and you just have to do it in two parts. You'd actually get 114,453, and this would be 1 million. Interesting because it doesn't reduce. Okay, but that's how you would do exact yes. What did you get for the fraction? Oh, it's supposed to be negative 147.1. I think that's what's messing you up. All right. Yep, my bad. Anybody else have a question? Would I be okay with the decimal, even if it said exact? Yeah, because that decimal is exact. All right. Find the first term. These are some crazy questions that are just reviewing stuff we've already learned. The sixth term should have been the first term times the ratio 6 minus 1 times. What can I put into this formula? Can we work that backwards? How are we gonna, I'm not even gonna bother to type it in my calculator other than to divide it. Does that seem okay? A sub 1 equals 0.1 divided by 0.2 to the fifth. That way I don't have to figure out what 0.2 to the fifth is because it wants to do it in scientific notation and I just want to type it in all at once. Do I need to change that to a fraction? No, it's exact. You can if you want, but nope. Yes, 625 over 2 is right. Okay. Next one. Find the R if we know the 10th term. Well, the 10th term should have been the first term times R 9 times, yes? So the 10th term is 7680. The first term is 15. Do you vaguely remember me at the beginning of the lesson saying I might have to do a ninth root somewhere? Yeah. Something stupid like that? Divided by 15 is 512 to the 1/9 power. Okay, that's all it asks for, yes? Okay, that wasn't too bad. All right, number 5 has an error on your worksheet. Write a geometric sequence that has 3 arithmetic means doesn't work out so well, okay? Let's go with a geometric sequence that has 3 geometric means between. So what am I going to do? Yeah. The Hofbauer method is draw 3 spaces. 5, 6, 7. Okay. So 7 was multiplied by how many r's? 4, right? It's r to the 4th. Now what? Divide and then do to the 1/4 power. This is an interesting question. Everybody's going to go with 3. Does anybody know what else it could have been? Could it be a -3? It's a -3 to the 4th power would still be positive 81. Okay. In theory, this could be -3 because you did an even power, so it could be plus or minus. I would accept both. I'm not going to say you have to have both. How's that? Okay. If you multiplied by 3, you'd get 21, 63, and 189. How did I do? Someone checking me? What if I changed it to -3? This would be negative. This would still be positive, right? And then this one would be negative. All right. What? Yes, it would work. It'd go positive, negative, positive, negative, positive. So it could be either one. I'm not going to make you say that it could be both, okay? All right, because I think you'll all forget. The next thing we're going to talk about is the sum formula for a geometric sequence. This formula works for what's called a finite sequence when you know I'm adding up 10 terms or 12 terms, okay? And yeah, sequence that ends. Good job. The formula should really probably be written like this, just because this is how you're going to have to type it in. So could you write that down on your paper? I'd really, really like you to write it this way on your paper, though, because it's not going to be written that way on the quiz, but you have to know that you really need extra parentheses there. You really only need them if r is negative, but I just always practice putting those there. Let me give you an example. What is the first thing, if someone wrote that down on their paper before they went to type it in, what is probably the first thing they're going to do? They're going to go plus positive, plus positive. Yes? This one is right? Down here, there's not, but up here, if this was meant to be a -2 to the 6th, can you go plus positive? No, because this, well, no, because this should have turned out to become a positive, right? And then it should have been a minus here. All right, let me back that up so we're not so confused. But what they should have done is when they go to type it in, they need to put an extra parenthesis there, okay? So you don't need an extra parenthesis down here. Now, if it's a fraction, you still really don't need an extra parenthesis, but you can always put an extra parenthesis here and here to get it right. So all I can say, please type these in your calculator the rest of the period, because if you're not getting this, I would love to come over and help you figure out what you're doing wrong, okay? But you will mess this up on the quiz if you don't practice it. Now, I don't know. You know what? I'm going to do this out of order. Let's do this example 3, Rebel. I didn't do it out of order earlier today, but it's a little confusing. Let's practice at least one of what we just did before we try to learn a new formula. Find the sum of the first 12 terms. That means it's finite. We want this sum of 12. Okay, the formula then would say the first term. This is interesting. We don't need to know the last term like we did before, right? It's just 1 minus r to the n, and it's also not n minus 1. Do you notice it's n over 1 minus r? Okay, what are we putting in? 6. Now, be careful, because I wanted to say it was 1.5. Okay, it's 7.5 divided by 6 to find r, right? 1.25 or 5/4, but 1.25 will work. So it's 1 minus 1.25 to the n. What's n again? 12. All over 1 minus 1.25. Okay. No. Yeah, the 6 doesn't need parentheses. That's a good question. Yeah, these used to be a nightmare when we didn't have parentheses on our calculator, and we had to like figure out the order to type it in to make it work. You know, take this answer, do this to that answer. Okay, this is the one I think I was thinking of earlier, because it's like 67.552734338. I'm just kidding. It's the 12th. I did to the 6th. Okay, it is nasty, but it's not that one. 325.2459655. You know what? When I do math enter, nothing. How many of you get it to work? I don't know why some of them do. We tried to figure it out earlier. What do you get? Like that? Like that? Yeah, it's the newer ones that don't, and I don't, yeah, I don't know why. We could figure this out the long way, but I promise I will accept this for that answer, okay? I don't care. All right. I'm going to move on to talk about this formula. We'll do some more practice with that one, but right now, the sum of an infinite geometric sequence. You can only do this if it converges. Does anybody remember how we know if it converges? If it's approaching a certain number, but what we're multiplying by has to be making it smaller and smaller. So the idea is r has to be less than 1. Now it can be positive or negative, but its absolute value has to be less than 1. Let me give you an example. 2, 4, 8, 16, 32. Is that going to approach a single value? Every time I add on another term, it's going to grow, right? So I can't find the sum of that because it's going to keep growing and growing and growing. If I did 32, 16, 8, 4, 2, 1, 1/2, 1/4, I'm eventually adding smaller and smaller and smaller and smaller amounts so that it will approach something, because eventually I'm almost adding nothing. Does that make sense? Okay, to figure out what that sum is going to approach, so if these were all pluses in here instead of commas, okay, what would it approach? It's this little formula. That's all you have to do. The sum of the infinite sequence is the first term divided by 1 minus r, and you would need parentheses like that. So do this one for me right here. What's the first term of my sequence? Okay, why does this one work again? Because r is, yeah, r is less than 1, right? So r is 1/2. So I'd have 32 over 1 minus 1/2 is 64. Everybody knows that 32 divided by 1/2 is not 16, right? 32 divided by 1/2 is 64. We okay? Yeah. All right. If you started adding this up, guys, try it. 32 plus 16 plus 8 plus 4 plus 2 plus 1. I get to 63 by here already. But then I did plus 0.5 plus 0.25 plus 0.125 plus 0.0625. I'm up to 63.9375. But what I'm adding is like 0.00 something, right? Do you see where it's just going to approach 64? Because eventually you're adding little tiny numbers. All right. The limit is. Say that again. No. Yes. The function value or the sequence value term values are going to approach 0. This is what the sum is going to approach. If you added all the terms up, it will get closer and closer to 64. All right. Where was the next one? Here. This is at the top of 8b. It says find the sum of the geometric series. This is how I know I have to use that formula if it even works, because it's infinite. Do you see it's not adding up 12 terms? So this is the infinite. Oh, that's supposed to be an infinity. Bad infinity. Okay, that's how many. And the formula is the first term over 1 minus r. But it only works if r is less than 1. Can we figure out if r is less than 1 here? 8 over 40 is 0.2 or 1/5. Okay, so what's the first term? 40 divided by 1 minus 0.2. So this is going to approach 50. Why didn't I use this again? I need somebody to clarify. I don't have an n, right? I don't know how many terms I'm adding up. This is an infinite sequence, and I can only find its sum if r is less than 1. All right, moving on. Find the sum of this. Uh-oh. This is once again, right? Uh-oh. Okay, but it also says this. Yeah, you could find the first 7 terms and add them up for sure, but we can also use the formula. The ... really didn't matter because it was telling us that only one is the sum of 7, right? You couldn't find the sum if it said find all of them, because r is what? Yeah, it's divergent. The sequence is divergent. R is 4. So you can't do an infinite, but you can do 7. I thought for a minute you couldn't do it, but so you can do 7. You take the first term, which is what? -1 times 1 minus r, which is 4 to the 7. It's not n minus 1. All over 1 minus 4. You don't need it this particular time, but I always practice putting those extra parentheses there. Please be typing this so I know who's having trouble. I always have to remember to do that right arrow thing once you get up in that little 7 spot. Yeah, or I have the whole thing typed up in the top. Oh, I missed a parenthesis here, didn't I? Okay, I need to know if you're getting this answer or one of us did something wrong. Quite likely me, but... Who said not? Okay. Help somebody next to you. I can come. Oh, that'll do it. Sarah, did you figure it out? Okay. The next one says find the sum of the geometric sequence is. What do we not know this time? We don't know what n is. Can we do this without knowing what n is? We can? But it wants us to stop with this term. Okay. Yes, we got to find n. Okay, guys? A sub n equals a sub 1 r to the n minus 1. So a sub n is what? 0, 3, 1, 2, 5 equals 8 times 1/4 n minus 1. Ooh. Okay, if we divide by 8, can we do a math enter to make that nicer? After we divide by 8, I got 1 over 256. Did someone get that? I love this question, but I wouldn't ask it on a test or quiz, I don't think. Anybody remember? Can we take the log of both sides because n is in the exponent? Okay. Do you want to take the log or you want to do it another way? Okay. Let me tell you how I would have done this if I was thinking about sequences. I would have typed this in my calculator. Remember how to do that? In the u sub n equals 8 times 1/4 to the n minus 1 and to the power of n minus 1. And because it's explicit, you don't even need to put in like the first term or anything. Then you could go down and you find out, oh, right about here is the term 0.01325 and it said n was 6, right? So we could do trial and error even. This is what I'm going to tell you. This is a power of 4, guys. If you rewrite this as a power of 4, 4 to what power is 256? 4 to the 4th. What did you try? This is what you get. This is a power of 4. This is 1/4 to the 4. So then what happens? It works with logs. It works by trial and error. I'm not going to ask it on a quiz anyway. So we okay to go on? We're not done. Because what did it ask us to do? Okay, so we need the sum of 5 terms where the first one was what? And then it's 1 minus r, which is 1/4 to the 5th, all divided by 1 minus 1/4. Okay, I put 1,000 parentheses in there approximately. Yeah, I did it totally different, but I did get the same. That one my calculator did, 341 over 32. Did anybody get in that decimal or not getting that decimal? No? Anybody stuck? All right, we got a lot of problems to do here. You want to do this one? You can just do this with your summation key, right? You could use the formula because the first term is 5 and r is 1.06 and you're adding 11 terms, yes? So this would work. If you have an older calculator, this is a little bit tricky because you would need this. You'd 5 times 1.06, but when you do to the power of, you need parentheses around the n minus 1 on the really old calculators. But you could just use that summation thing. I don't know what it comes out. What do you get? Does it 651? Thank you. That's a 2. All right. It's disgusting that I'd take a decimal. Can we just move on? Okay. Find the sum of the first 16 terms. This looks tricky, but what is this called? It's the recursive. What does this mean? Negative 2a sub n minus 1. What does that mean? Negative 2 times the previous term. So what does that mean? R is negative 2. A sub 1 is... Okay. Sum of 16. What am I going to type? And you can put extra parentheses on the bottom. You really don't need them. But it's because of this power, you have to have these parentheses. Okay, that's what I got. But it doesn't mean I'm right. Anybody still not getting it? All right. These all say find the sum of the infinite sequence. Yeah, there's not infinity in your calculator. The formula is the first term divided by 1 minus r, right? We'll find you the infinite sum, but only if r, okay, tell me if r is less than 1. Can you tell on this one? R is 3/8. We'll come back to it. What's happening here? R is 1/2. Everybody okay? How do you... Well, I'm not sure. If I put in a 1, I get out 1. If I put in a 2, I get out 3. I put in a 3, I get out 9. What do you think? So this one is not possible. Okay. Nice try, Hoffbauer. Yes, exactly. And we'll never live it down. All right. Let's go back and do the sum formula. The sum of infinite terms is, what's the first term here, guys? 13. You can put in a 1 and it will come out 13. Over 1 minus 3/8. Yes, this one is 10 divided by 1 minus 1/2. You should be able to do that one without a calculator. Come on, 1 minus a half is a half. 10 divided by half is 20. We can do that. All right. Yeah, I'm going to put down 5. Yeah, you and a lot of people. Okay. These guys, I don't know why we get to this chapter and everybody thinks these questions are hard. These are exactly the same questions we did in chapter 5. Exactly. Okay. Car is depreciating. The original car was 22,000. Depreciating by 18% means what? Or 0.82, I think, right? Yeah. From 2009 to 2015. 6 times. Now, I can go through this great big explanation how 22,000 is term 1, okay? And that happened in 2009. So 2010, 11, 12, 13, 14, 15, that was 6 terms. Just remember it's not n minus 1. It's just the same thing we did in chapter 5, okay, when we did exponential growth or decay. Because somebody always thinks, well, I have to do 6 minus 1. No, it's just, okay. Do you know what I'm talking about? Okay, nobody's going to do that. What do you get? 88. 1. Okay. And no, is that right? Okay. All right. Down here we have the population started. Yeah, this is a huge one. I better type it in or I'm not going to be here for a half hour trying to listen to you guys read it to me. Okay, that big number is doing what? It is 1 plus 0.235. Do you really think Florida could be growing by almost 1/4 every year? I don't think so. That means like every year, every family of 4 added 1 more. Okay. That's true. Have you seen the Florida population? They're kind of old down there. So my estimation is almost 9 billion people, right? Okay. All right. We got one more question. We can do this. Guys, I need to record this. Let's get this done. Okay. This is what he earned the 10th year. What was his pay the first year? How many raises did he get by the 10th year? 9. So A sub 1 times what? Increasing means 1.045 or 1 plus 0.045 to the 9th equals, yes. Yeah, we're going to take 50,081.41 divided by 1.045 to the 9th. Yep. Okay, so his starting salary was about that. Now it says to the nearest dollar. Oh, I bet I didn't read that right earlier. How much did he earn for the first 10 years? That means the total, guys. So we're doing what? The sum is the first term times what? What's our rate? 1.045, because this is what we multiplied by, to the 10th this time. Okay, type. How fast can you type? I can type, I just can't remember to hit right arrow. Uh, 13 if we round to the nearest dollar, right? Because I finally read the question and it said nearest dollar. All right. Are we good? Yeah, if he made negative money, that would be a problem. So we're working on page 615, yes?